Hey everyone, welcome back to the channel. Today we are diving into one of the most important parts of Python, which is exception handling. So, first thing first, what exactly is a error? In Python, we mainly deal with two kinds of error. The first one is the syntax error. So let's say I write this print hello and I forget to put a closing parenthesis. If I run this, it will give me a syntax error. So syntax error is like a grammar mistake in Python. They occur when the code isn't written correctly, like in this case. So Python is saying by giving the syntax error that, hey, whatever you have written, I'm not able to understand it. So if I have, let's say, print hi, and then I have print hello, and maybe I have another line here, print good morning. What do you think? Which of these lines will be executed? Will hi get printed? Hello, we know there's a syntax error in the second line. What about good morning? Will good morning get printed or not? Let's run it and check. So no, it is not running anything. So when there is a syntax error, Python would not run anything because first it will just go over each line and see if it understands what it has to do. If there is no syntax error, only then this code would be executed. So although there is no syntax error in the first line, even the first line is not executed. So that's the first type of error, the syntax error. And the second is the exceptions. We also call it runtime error. And this occurs when syntactically your program is correct. There is no syntax error in your program. So, but while running the code, Python hits something which it doesn't know how to deal with. So let's say you say print 10 divided by 0. Now there is no syntax error, there is no mistake as such. But Python doesn't know what to do about it. So it gives us zero division error. This is called as exception. It is saying that division by 0, it doesn't know how to handle. So syntax error are caught during the code parsing when the Python interpreter is passing this code, and exception occur during runtime. So today we are specifically talking about exceptions and how do we handle these exceptions. Now, what if I have print hello before this exception occurs? And maybe I'll add one more line, print hi. What will happen? What do you think? Hello will be printed? Hi will be printed? What will happen? There is an exception, of course, in the second line. But what about hello and hi, the first and the third line? So hello is getting printed. So first line will be executed. There's no syntax error, everyone. So Python will go ahead and run each line one at a time. So it will run the first line, it will print hello. Then in the second line, an exception is encountered. An exception occurs. So the code execution will stop and it will raise a exception. This is called as raising an exception. What is the name of the exception? Zero division error. So let's see the common built-in exceptions in Python. So we have already seen zero division error. There are other exceptions also. So if I say int 20, this 20 is a string because it's enclosed in quotation. And this int function converts a string to integer. So this is working, but what if I give 20 like this? Can this be converted to integer? The answer is no. So in this case, again, there is no syntax error, but while running the code, Python realized that it cannot, run this operation. So it's giving or raising a value error. Cannot convert string to integer. Another one is type error. Let's say I say age plus 25. Can a string and an integer be concatenated using a plus operator? No, it cannot be. There is no syntax error once again. So it is raising this type error exception. Another one is index error. So let's say I have a list here, 1, 3, 5, and let's put it in a variable. Now if I say list 1, 6, do we have an item at index 6? No. So it will give me index error. Let's try more key error. So let's say I have a dictionary and I have A here and the value is 1. Let's save it in a variable. If I do D A, it works fine because I have a key called A. But if I do B, it will give me key error. So these are all built-in exception classes. When I say key error, there's a class called key error or the key error exception. Likewise, you have classes called index error, type error. All of these are classes. And Python uses them to tell us what went wrong and where. Now, let's say I don't want to stop the execution of my code when the exception occurs. I want to handle this exception and move on with my code. Right now, what's happening? If as soon as the exception occurs, the execution of the code stops. We have seen this here. But I don't want to do that. I want to continue running my code even when the exception occurs. I just want to handle the exception and move on. And that's where exception handling comes into picture. And to handle these exceptions, Python uses try except block. Now let's first look at the syntax of this. So you have try, colon, and then the code, which is risky code in the sense that which is prone to throwing an exception. Maybe you're taking an input from the user. What if the user enters an input which is of incorrect data type? Or it could be any other scenario. Risky code. And so you put it in the try block, and then you have the except block. In except block, we mention or we specify what to do if that error happens. So what are we doing here? We are basically saying that let's put a code which we think can have an exception or an exception can occur inside the try block. So let's try running that code. If it runs without any error, that's good. The except block, the code in the except block will never be executed. But if there is an error in the code, in the try block, inside the try block, the except block would be executed and it will handle the error. So that is the idea of try except block. Now let's see it in action. So let's say I have this number which I take as input from the user. Let's convert it to integer. Input and enter a number. And then we'll just go ahead and do print 10 divided by the number. And now this is my risky code. I want to put it inside the try block so that I can handle it if any exception occurs. So I'll just simply do this properly indented code. And then I'll have the except. And here I'll say, I'll print some error occurred. Let's try running it. So if I give a number, let's say 10, which is fine, no exception, right? Nowhere. So this block gets executed and this except block never gets executed because there was no exception. Let's try it one more time. So now let me enter 0. So some error occurred. Which is the error? We know that. So zero division error. Zero division error. So yeah, zero division error is occurring here. Let's say this time instead of a number, I write the number like this. So again, it's giving some error occurred. This time it's a value error. So yeah, this except block is working. But what if based on the kind of exception being raised, whether it's a zero division error or a value error, I want to handle it differently. So in this case, you can specify the error also, the exception also. The name here has to be exactly the same. So this is called zero division error. This name has to be exactly the same. We'll say except, just copy pasting it from up above. And this is how it will be tackling it. So we'll say number cannot be 0. And now let's try with 0. So it's raising exception here, zero division error. And this except block is executed because it is indeed zero division error. But what if I give 20 here? In this case, I don't have an except block to handle value error. So if you don't specify anything after except, it will handle all sorts of exceptions. But here we are saying that this except block will specifically handle zero division error. So we can have one more except here for the value error. And we can print here, enter a number. Let's try it out with a number now. 0, number cannot be 0. 1, enter a number. Another thing you must have noticed is in one try except block, you can only have one try, but you can have multiple except like we have here. You can have more than one except block. And for everything else, for all the other errors, let's say you are not sure which other exceptions might be raised in the code, you can say print some error. And this would be executed. So guys, what happens when we get an exception? We know that the except block would be executed, but what happens to the code? Does the execution of the code stops? So if I have print good morning here, will this be executed? Will this run or no? Let's try. So we'll get an exception and the good morning is getting printed here. So that means the execution of the code is not stopped. Unlike previous scenarios where we were not handling exception, we were getting an error message and the code execution was also stopping on the line in which we were getting the error. But here, our code, once we have handled the exception, the code executes normally. Now, the try except block also comes with two other statements, which is else and finally. Else. So let's just print runs only if no exception occurs. So this else block will be only executed if no exception occurs. And then you have another one, which is finally. Finally would be executed irrespective of whether you have an exception or you don't have an exception. So no matter what, finally will be executed. Runs no matter what. So let's try it. So let's say we don't have an exception, then the else block should be executed. So you see the else block is getting executed, and finally should also be executed because it runs, doesn't matter exception or no exception. Now, what if there is an exception? Then the else block will not be executed, but the finally one will be executed. You must be wondering where you would use finally, because it is anyways executed. Doesn't matter if you have an exception or you don't have an exception. So you would use finally for final cleanup, right? Let's say you are opening a file, and a file which is sitting on your system, on your desktop. From Python, you're opening that file, doing some number crunching, and then you are supposed to close that file once you have done your processing on the file. Now, let's say while processing the file, some exception occurs. So you're handling that using the except block. But once you have handled that exception, you would want to close the file. You would not want to leave it open. Otherwise, somebody could accidentally change the content of the file. So it would be a good idea to close the file, even if the exception occurs. And if there is no exception, of course, you would want to close the file. So closing operation you can put inside the finally block. So that's one place where you would use this finally block. Now, what goes behind the scenes when these exceptions are raised? What is really happening? So every error that we have seen so far, the index error, the key error, the zero division error, they're all classes, as I've said previously. They're all classes, and they inherit from a Python's built-in exception class. So these are child classes of the exception class. So whenever Python hits an error, a runtime error, it creates an object of that class and raises it. So it will create an object of the key error class and raise the exception. So you have all these inbuilt exceptions, but let's say you're working on your own project and you want to create your own custom exception. So you can do that as well. You can create your own custom exception. So let's say for you, you're working on this age data. Maybe you are hiring people and the age of the person cannot be less than 18. That's the policy of your organization. So you can create a class for this custom exception. You can call it whatever you like. You can give it a name of the built-in class also, exception class also. Let's just call it age below 18. And this class, for it to be an exception, should inherit from the exception class, inbuilt exception class of the Python. And I'll just pass here, empty class, nothing going on. Now let's say age of the person who has interviewed with us is 16. We'll have a check. If age is less than 18, We want to raise a exception. So you use the raise keyword to raise the exception. And the name of the exception, age below 18, and whatever message you want to give. So I'll just say age cannot be below 18. So this exception is raised, as you can all see. Just in this way, inbuilt exceptions were raised. And then you can handle it in the similar fashion in which we were handling the inbuilt exceptions by using try except block. So again, another one, let's just try with 20. Well, let's see if the exception is raised or not. So let's just change it to 20. Now this condition is false and exception is not raised. Another one, let's say you're not sure what kind of exception is raised, right? And if you use something like this here, right? So you're not put an exception name here. If this block is executed, you would not know what the exception is, right? What is causing that exception? So we have a way out for this as well. Let's just take this code down. So let's say you don't know what kind of exceptions might be raised in this program, but you want to handle it, and also you want to print what exception is raised. So how can you do that? So for that, you can say for except exception as E and some say error, and you can go ahead and print your E. So whatever exception that has occurred, you are saving it in this variable E and then printing it. Let's run it. If I have 0, so this one is giving us error division by 0. And if we give a number here, one, 1 cannot be converted to integer. That's why it's giving us an error. Error invalid literal for integer with base 10. That means you cannot give 1 here. You have to give 1 like this. And this works perfectly fine. So what are the best practices here? Best practice is if you know what kind of errors might occur in your code, what kind of errors your code is prone to, then handle those exceptions first, the specific exceptions. Then use finally block to clean up, like closing files, database, closing the database connections, things like that. And use custom exceptions for clearer logic, like we have done here. And you can use raise keyword when you want to, throw an error when needed. And it's great for validation and debugging the code. And that's it. You now know everything to get started with exception handling in Python. If this helped, please like the video, subscribe for more, and drop a comment below. Thanks for watching, and see you in the next one.